Hello. This was a question from the assignment that gave you a little bit of trouble, at least to most of you. So I decided to go over it in this video, and so you can see what you were asked to do. So it says, show that the curves, and then one is given by y equals e to the minus x. I'm going to actually write y1 equals e to the minus x because I want to distinguish them, and then the other one y2 e to the minus x times cosine of x. We want to see that these two curves are tangent at each point common to both of them. And then, period, the second part asks you to sketch the two curves over a given interval over here between minus pi over 2 and 3 pi over 2. But that doesn't mean that the interval applies to the first part of the question. The first part of the question is in general. We want to show that at any point where the curves intersect, so they have a point in common, they are tangent to each other. So the interval is just for the sketch because, well, it will be complicated to do the sketch or the whole real line. Let's look at the sketch first so we get an idea of what's happening. I have here the sketch of both functions, f1 and f2 are called over here. Note that this is just whatever window that the calculator decided for me, but I'm going to change the window because I know exactly where I want to see this function. I want to see it between negative pi over 2. Yes, you can write it like that, the calculator will understand. And for the maximum of x, I want 3 pi over 2. We'll see about what values of y are convenient for this interval, but, well, you can see the functions over here. It looks like we could benefit from zooming in a little bit more so we can see better what's happening around 0. That seems to be a relevant point. So I'm going to zoom in there to see what's happening, even though I'm not going to be able to see the whole interval anymore. I want to see what's happening over there. So you see, it looks like at 0, the red curve and the blue one are coinciding. So it also looks like at that point, the graphs have the same tangent. That's what we want to prove, but not just at 0. We want to be able to prove that for any other point that could be farther away, I don't know, where the two functions intersect. So the first thing I'm going to try to do is to find actually when do those two curves intersect. So I want to know for which values of x, e to the minus x is the same as e to the minus x multiplied by cosine of x. So that means if I rearrange this, e to the minus x minus e to the minus x times cosine of x has to be equal to 0. So e to the minus x is common factor times 1 minus cosine of x has to be equal to 0. Note that the exponential function, this is never 0. So that means that this factor has to be 0. So we are trying to see when cosine of x is equal to 1. But that we know perfectly fine. We know that this is true for x equal to any multiple of 2 pi. So I can write 2 pi k, and k can be an integer. Yeah, so this is true for 0, as we saw in the picture, but it is also true for 4 pi or minus 14 pi. So any multiple of 2 times pi. So what we need to check is that the tangents are the same when we have points of intersection. But if we have points of intersection, let me just sketch here. We have a function here, we have a function here, and here we have the point of intersection. So maybe this is a bit of a bias picture. Let me try again with another one. You'll see why. Let's say this is one function and intersects another one here. So I'll draw the tangent of the second one like this and the tangent of the first one like this. So even though they intersect, the tangents don't have to be the same. We want to prove that in this case they are. But for the tangents to be the same, well, they need to have a point in common. Check, we already have that. And then they need to have the same slope. So what we want to see is that when x is of this form, so 2k pi for any integer k, then the slope of the first curve and the second curve is the same. So we need to check what it is, this derivative of the first function, that's minus e to the minus x, and we also need to check what is the derivative of the second function. Well, here we have a product rule, so minus e to the minus x times cosine of x if we take the derivative of the first factor, plus e to the minus x times the derivative of cosine, that's minus sine of x. So I'll take minus e to the minus x as common factor, and I'll be left with cosine of x plus sine of x. We wish to evaluate both those derivatives at the points of the form 2 pi k. So when I do in the first one, 2 pi k, the result is going to be e to the minus 2 pi k. When I evaluate it in the second one, the result is going to be, we're going to have, oh, sorry, I forgot the negative sign in the first one. For the second one, we are going to start also with a negative sign, and then we have e to the minus 2 pi k times, and then we are going to have cosine of 2 pi k, which is 1, plus sine of 2 pi k, which is 0. So all of this actually is just minus e to the minus 2 pi k. So what did we show? We showed that the intersection of the, sorry, no, don't write there. If a point is common to both curves, so if x is equal to 2 pi k for any k integer, then the slope of both curves is the same, and that's for any k in the integers, and this is what we wanted to show. Then we also need to include a sketch of the two curves in the given interval, but that's just well, using our calculator and copying a more or less nice picture of that, and that's it.